In this lesson, we are going to review the process for solving absolute value equations. Before we begin solving absolute value equations, it is worth taking some time to review the absolute value as a grouping symbol and as a potential operation to worry about. So you might remember that the absolute value is written like this, and an absolute value equation could equal anything. In this case, we have that the absolute value of x is equal to 3. Reminding ourselves of the definition of the absolute value, we are looking for those numbers x whose absolute value is 3. We are looking for those numbers x whose distance from 0 is equal to 3. So obviously, we're going to have two different answers. We're going to have the positive 3 and its opposite, the negative 3. Depending upon how difficult the inside of the absolute value is, will determine how difficult it will be to solve the equations. Taking this first equation as an example, the absolute value of z minus 13 is equal to 21. Remember what the absolute value is asking us for. It is asking us to identify a number's distance from 0 on a number line. In this example, we don't have a number, but rather an entire expression, z minus 13. Fortunately for us, the same logic holds. We want that entire expression, that entire inside of z minus 13, to have an absolute value equal to 21. Like we saw in the last example, there are two different ways for z minus 13 to have an absolute value equal to 21. Z minus 13, the inside expression of the absolute value, could equal 21, or z minus 13, the inside expression of the absolute value, could equal negative 21. Both of these cases and both of these examples, both of these equations, will give us a solution to the original equation. Over here on the left, we have that z is equal to 34, and on the right, we have z is equal to negative 8. Looking at these examples, we can see that no, we did not end up with answers that were opposites of one another, and that's okay. The answers do not have to be opposites of one another. But there is an interesting relationship that we will look at throughout this lesson between these numbers, the 13 and the 21, and the distances that they are on the number line. But solving an absolute value equation is this simple. Looking for the inside to have an absolute value equal to the number on the right. Now, in some cases, it's not as easy as simply just splitting the equation. In some cases, we have a variable on both sides of the equation. In these situations, we can engage in the same practice, but realize that there's going to be a difference, a key difference, at the end. So again, here we have x plus 10. We want the absolute value of x plus 10 to equal 4x minus 8. There's two ways to get there. X plus 10 could equal 4x minus 8, or x plus 10 could equal negative, or the opposite of 4x minus 8. Just like with our first example, we had two ways to get there, 3 and negative 3. And in this example, we had two ways to get there, 21 and negative 21. Here we're going to have the same situation. We'll have 4x minus 8 and negative, or the opposite of 4x minus 8. On the left, we'll subtract x from both sides and add 8 to both sides, and we'll end up with 18 is equal to 3x, which gives one solution, x is equal to 6. Over on the right-hand side, the right equation, we'll first send that negative through and change the signs of both the 4x and the 8. We'll engage in the same practice. We'll look to get x by itself. Here, because this negative 4x is negative, I'm going to move him over to the right, and then I'll kick the 10 over to the 8 and make it negative 2. Divide to finish, and we get another solution of x is equal to negative 2/5. Now, for what we're going to do next, we have a little bit of an issue. Sometimes the possibility exists when you do this that you create what's called an extraneous solution. An extraneous solution is a solution that comes up while you're solving, but in fact, if you try to substitute it back into the original equation, it will not work. This tends to happen in very specific situations, And unfortunately, absolute value equations are one of those situations, and especially those absolute value equations where there's another occurrence of the variable on the other side. So let's take a look at see what that looks like. Let's begin by testing our answer x is equal to 6. If we test our answer x is equal to 6, we get an equation that looks like this. And we want to convince ourselves that that's actually true. The absolute value of 16 equal to 4 times 6, which is 24, minus 8. That makes a 16. The absolute value of 16 is 16, and that side actually works. So this answer, we know, is good. Where we're going to have an issue in this particular example is this number. If we try to substitute that number in the place of x, similar to what we did with the 6, we're going to end up with a situation that ideally we would catch any time it came up. Now, that becomes the responsibility of the mathematician to make sure that they are actually checking for this, but it really does, early on in this lesson, really only does come up in this one specific scenario. So let's try substituting the negative 0.4, and it's going to be a little bit easier with the decimals. So we'll do 4 times negative 0.4 minus 8. Over here on the left, negative 4/10 plus 6 gives us the absolute value of 9.6. Over here on the right, 4 times negative 4/10 is negative 1.6, or negative 1 6/10, minus 8, which gives us a total of negative 9 6/10. Unfortunately, the left-hand side still only has that positive answer. So while our work over here got us a solution that theoretically should work, the presence of that x on the other side of the equation created this extra solution that in fact doesn't work in the original equation. We will see this throughout this year. This happens occasionally with square root equations. It happens occasionally with other different types of more complicated equations. So some of our more polynomial, sort of larger equations. But in this case, we run into it with the absolute value. So you just want to make sure in these situations where you have this extra x on the other side that you're being very careful to check your answers. It's not a bad idea to check your answer all the time, but in this particular case, it's especially important to check your answer because you know that there's the potential for a problematic extraneous solution.